Hey class, welcome to our last section for Inside Earth, which is our last section for science for this quarter. So I'm excited to go through this lesson with you and to learn more about what's inside the earth and how mountains and landforms are formed. So before we dive in, let's review what we learned last time. We talked about the different continental shelves of the crust and how mountains are formed. And mountains can form by two plates moving together and kind of crumbling and forming mountains like this. We learned how mountains can be a continental shelf, usually an oceanic shelf would be pushed under and a continental shelf would come up. And that's how mountains are formed. And also hot molten lava would come out and help form the mountain. We learned how two plates can move across or move apart, and molten rock will come up through and cool and harden. And we also learned how plates can move against one another. So in this section, we are going to cover, what does the title say? It says, what are volcanoes and earthquakes? All right, so we're going to learn what volcanoes and earthquakes are. So let's first pause and read our make a connection. So read with me. So, lava that erupts from a volcano is hot, molten rock that has traveled up to the surface from deep inside Earth. What changes to Earth's surface do you think lava can cause? What do you think? I think we should already know part of an answer, or know one answer to this question. There could be multiple answers. Well, in the last section, we learned how when two plates move across and molten rock comes up through those plates and it is hardened, it can help form lava. So that can that can start causing mountains, and that causes a change to the Earth's surface. So as we read, let's continue to look for ways that this molten rock that's traveled from deep inside the Earth coming up to the Earth's surface can change the Earth's, what the Earth looks like. So we're first going to learn about volcanoes. Volcanoes. Recall that molten rock can rise through Earth's crust and form volcanic mountains. An opening in the crust through which molten rock, gases, and other materials erupt or come out is called a vent. We can pause and look. Here is the vent that the molten rock, gas, and other materials are coming up and through. The lava coming down. So a vent as well as the mountain that often forms from materials that erupt through it is called a volcano. Volcano right here. And this is the mountain that's forming. Hot molten rock that is below Earth's surface is called magma. So right here, that is below the Earth's surface is called magma. Once magma reaches Earth's surface, it is called lava. So it's magma, 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 magma. Out it comes, now it's lava. A volcanic eruption can cause rapid changes to Earth's land and atmosphere. Lava, gases, very fine rock particles called ash, and small chunks of hardened lava called cinders can erupt from a volcano's vent. Here is a picture of a eruption, volcanic eruption, bringing lava, ash, and hardened lava and gases coming out. These materials can fly into the air and cover the ground. As a result, living things in the area may be destroyed. Gases, dust, and ash from a large eruption get into the Earth's atmosphere. This can affect weather both close to and far away from the erupting volcano. So all this gas and ash that's going into the atmosphere can affect the area that is close to and even the areas that are far away from the volcano. Volcanic eruptions can be very destructive, but they also build up new land. When lava from an eruption cools and hardens, new rock is produced. As this rock builds up, a mountain can form. Over time, wind and water break down volcanic rocks, and the bits of rock become part of the soil. So right here, here's a picture of when lava cools, it hardens into new rock. The black sand on this beach is broken down bits of volcanic rock. Volcanoes can be classified by their shape and by the materials they are composed of. Three main types of volcanoes are formed on Earth: composite volcanoes, shield volcanoes, and cinder cone volcanoes. All right. So here is our first one that we're going to learn about. This is a composite volcano, is Mount Fuji, located in Japan. Composite volcanoes have layers of hardened lava that alternate with layers of ash and cinders. So composite volcanoes are generally tall and wide. They often have very steeply sloped sides that are composed of alternating layers of hardened lava, ash, and cinders. Mount Fuji in Japan, Mount Shasta in California, and Mount St. Helens in the state of Washington are examples of composite volcanoes. And here is our next volcano we're going to learn about: the shield volcano and Kilauea, located in Hawaii. I'm not pronouncing that right. So shield volcanoes are composed mostly of hardened lava and have gently sloping sides. So shield volcanoes also can be tall and occupy a large area, but they are usually not very steep. Instead, they have gently sloping sides that are composed mostly of hardened lava. As the lava cools and hardens, it forms thin sheets of rock that build up around the vent. This word Kilauea and Mauna Loa on the island of Hawaii are examples of shield volcanoes. Cinder cone volcanoes are usually relatively small. Most are less than 300 meters. So here's your similar cinder cone volcano in Wizard Island, located in Oregon's Crater Lake National Park. So most are less than 300 meters, about 1,000 feet tall. They are not made of lava, but mainly formed from cinders that erupt from a single vent. Wizard Island in Oregon, Sunset Crater in Arizona, and Paracutin in Mexico are examples of cinder cone volcanoes. Each year, about 50 to 70 volcanoes erupt on Earth. Scientists have noticed certain patterns in the locations of the world's volcanoes. For example, many volcanoes are located near plate boundaries, in areas where plates are moving apart. Volcanoes form as molten rock travels upward between the separating plates. Other volcanoes form in areas where plates are colliding and one plate is sinking down under the other. Parts of the sinking plate melt, producing magma. That magma often rises and breaks through the crust nearby, creating volcanoes. You can see this picture. So more than half of the volcanoes on Earth are located at plate boundaries around the Pacific Ocean. And this is called the Ring of Fire. The plate boundaries at the edges of the Pacific Ocean are home to a great many of Earth's volcanoes. And as we just read, this region is known as the Ring of Fire. Not all volcanoes form along plate boundaries. Some form above hotspots. A hotspot is an area in the mantle that has a higher temperature than other areas near it. A hotspot melts rock, forming magma that rises and breaks through the crust. When a plate travels over a hotspot, a chain of volcanoes can form. The chain of Hawaii Islands continue to form as the Pacific Plate slowly travels northwest over a hotspot. So these islands are over a hotspot that form these islands. Okay, so here's your checkpoint for this section. Explain what a volcano is and describe where many volcanoes are located. Okay, and so before we read this section, let's look at these pictures to help us give an insider look of what we're about to read. So an earthquake occurs when rock underground suddenly shifts, releasing stored energy. The energy travels away from the earthquake's focus, causing the ground to vibrate. Here's the focus. Okay. The San Andreas Fault in California is located in an area where plates slide past each other. Many earthquakes occur along this fault. Okay, so when they're sliding past each other. Underground rock let's start reading this. Earthquakes. Underground rock that is under pressure can suddenly shift. This creates a vibration of the ground known as an earthquake. So when plates shift suddenly and create this huge vibration, which is an earthquake, stored energy is released by the shifting rock, causing the ground to shake. Earthquakes usually occur in the crust near Earth's surface. Most earthquakes are sudden events that last for less than a minute. Me and my family experienced an earthquake in Utah a few months ago. Sometime this year, and it was pretty wild. For about, I don't know, 5 to 10 seconds, it felt like we were on Jello. It was pretty wild, like the house shaking and moving. It was crazy. Okay, so recall that a fault is a break in Earth's crust. Most earthquakes take place at faults near plate boundaries. Many earthquakes in California occur at faults along a boundary where plates slide past each other and pressure builds up. This plate boundary is part of the Ring of Fire. Earthquakes can also occur where plates collide or move apart. The point inside Earth where an earthquake begins is called the earthquake's focus. Right there. That's where the earthquake begins. Energy released by an earthquake travels outward from the earthquake's focus in all directions, moving in repeating patterns called waves. The point on Earth's surface directly above the focus is called the earthquake's epicenter. So right above the focus is the epicenter. Scientists have discovered that the energy waves produced by earthquakes travel in different ways through different materials. Studies of how earthquake waves travel have helped scientists determine what materials make up Earth's interior. All right, let's look at these two cool pictures. So seismographs are instruments that detect, measure, and record the vibrations of the ground during earthquakes. It looks like this one was probably really big and a big earthquake, while maybe some of these were small. Some scientists study earthquakes by drilling deep holes in the ground. The scientists record how the rocks in the area behave when an earthquake occurs. Although thousands of earthquakes occur on every day, most of them are weak and cannot be felt by humans. The amount of energy released by an earthquake is called its magnitude. So, however, how much energy is released from that earthquake's focus through the epicenter and how big it was is called its magnitude. Generally, larger faults produce earthquakes with greater magnitudes. Scientists around the world use instruments called seismographs to record and study the vibrations from earthquakes. The output from a seismograph, called a seismogram, helps scientists determine the magnitude of an earthquake and its location. A seismogram can also help in finding out the time an earthquake began and measuring how long it lasted. So let's pause. So depending on how much energy an earthquake releases, that determines the magnitude of the earthquake. Scientists use seismographs and seismograms to help determine the magnitude of the earthquake and its location. The magnitude of an earth is often described using the Richter scale, which is right here. The Richter scale ranks earthquakes according to the amount of energy they release. An earthquake with a given number on the scale releases about 32 times more energy than an earthquake with the next lower number. For example, an earthquake would be a micro, right here, the earthquake, a 2.0 earthquake, which is a micro in the micro class, 2.0, releases about 32 times more energy than a 1.0 earthquake. And a 5.0 earthquake releases about 1,000,000 times more energy than a 1.0 earthquake. So a 5.0 would be a moderate magnitude. Each year, Earth has about 17 major earthquakes, magnitude between 7.0 and 7.9, and about one earthquake, magnitude 8.0 or greater. And I think the one that was in Utah that we had was around the 7. It was pretty intense. I think it it caused an energy blackout in Salt Lake. So the strongest earthquake ever recorded occurred in South America in Chile in 1960. It measured a 9.5 on the Richter scale. So a great earthquake. The strongest earthquake in the United States occurred at Prince William Sound, Alaska in 1964. Dang, only 4 years after. It was measured 9.2 on the Richter scale. So 2 great earthquakes in about 4 years' time. We can look at some of the damage that is caused by earthquakes. Strong earthquakes can greatly damage roads and buildings, can change or destroy wildlife habitats, and cause landslides. The design of this skyscraper in San Francisco, California, helps keep the building stable during an earthquake. Pretty interesting. Okay, so these are our last 3 paragraphs, and then we're all done with Inside the Earth and all done with science for this quarter. You guys have been doing awesome and staying on top of it. Strong earthquakes can cause a tremendous amount of damage to Earth's surface in a very short period of time. They can cause the ground to crack, roads, buildings, and property may be destroyed, and power, gas, or water lines may break. As a result of this damage, fires can start. The habitats of plants and animals may be changed or destroyed. In mountain areas, earthquakes can cause landslides, which cause thousands of tons of rock and soil can slide downhill in seconds. A strong earthquake on the ocean floor can cause a tsunami, a series of fast-moving waves in the water. When the waves of a tsunami reach shallow water near land, they slow down and pile up, rapidly growing in height. Waves as high as 30 meters, nearly 100 feet, may crash onto the shore, causing great destruction. Some areas experience a greater number of earthquakes than others. When building in these areas, people can use materials and technology that help keep structures stable. Older buildings and bridges can be reinforced or made stronger to reduce earthquake damage. All right, so here are your last 2 assignments for Inside the Earth, as long as you've already done the other ones and have done the vocabulary word. So your last checkpoint is explain what causes an earthquake. And then your apply science is to answer this. Do you think that scientists can predict when an earthquake is about to occur? So in the text entry box, in your text entry box associated with the apply science concept assignment, write a paragraph explaining your ideas. If you think scientists can predict when an earthquake is about to occur. Okay, and then here's your glossary, which will help you with your vocabulary words. If you haven't done them, remember to use the definitions from the book. That way I can tell that you are also in the book. Do not copy and paste from Google. But that is it, guys. I hope you enjoyed learning about Inside Earth. Hope you are doing well with finishing out this quarter. I've been doing these recorded lessons to have more time to help you guys that have questions about the subjects and assignments, and some of you guys have been taking me up on that, which is awesome. Please reach out to me if you need any help, and I'm not for sure when this video will be posted, so I might see you in another recorded lesson for this week, but this is the last week of this quarter, so please finish strong, get caught up, and pass all of your classes. And I'm here, obviously, to help you, and I have time to do so. So let's connect for those that are struggling. But I know some are behind in assignments, and I can reach out to you guys and let you know. But I don't know if you're struggling, so please reach out to me. Okay, I'll see you guys in the next video.